This is Grand Admiral Rosine, following the physics directive to explain conceptual modern physics. In this video, we will explore gravitational time dilation. Previously, we discovered that acceleration is relative to local spacetime curvature. Gravity curves geodesics, the straightest paths through spacetime, and anything that resists those geodesics is considered accelerating. The shape of spacetime defines what counts as accelerating. Now, we will discover the consequences of this. To understand them, we must first take a look at the Doppler effect. Take an astronaut floating in space next to a spaceship. The spaceship is moving at the same speed as the astronaut, so that the pilot doesn't get too far for them to communicate. The spaceship also shines a light so the astronaut can see it. This causes several waves of light to release from the spaceship. The pilot wants to pick up the astronaut, but accidentally goes in the wrong direction. Now, because the spaceship is moving away from the astronaut, each wave is emitted farther away, stretching the waves out. This causes the frequency, which is the amount of waves per second, to decrease, lowering the energy of the light. This causes the light to appear more red. The astronaut tells the pilot to turn around, and so the spaceship redirects so that it is moving towards the astronaut. Now each wave is emitted closer, and so the wavelengths decrease, the frequency increases, the energy increases, and the light appears more blue. Now let's apply this to gravity. Say we have two twins, Alice and Bob. Alice is floating near a black hole, where spacetime is extremely curved, while Bob is far away, where spacetime is mostly flat. From Bob's perspective, light from Alice has to climb against gravity, decreasing its energy. Its wavelength expands and it redshifts. From Alice's perspective, light from Bob falls with gravity, increasing its energy. Its wavelength contracts and it blue shifts. But color is not the only thing that is relative according to spacetime curvature. Spacetime itself is. Remember that the light Alice emits has longer wavelengths to Bob, and the light Bob emits has shorter wavelengths to Alice. Now the two twins count time by using each wave peak as a tick on their clock. They can do this because, in their own frames, the light they emit travels at the speed of light. To Alice, it takes longer for each wave to pass, so her clock ticks slower. To Bob, it takes less time for each wave to pass, so his clock ticks faster. Bob ends up older and Alice ends up younger. That means that motion is not the only method of time travel. Your location can cause you to travel through time as well. The more curved your local patch of spacetime is, the slower your clock will run, causing time to seem to pass quicker for others. But remember that gravity is not just the curvature of time, it is also the curvature of space. Since Alice's time is compressed from Bob's perspective, so is her length in the direction of gravity. This is gravitational length contraction. If you enjoyed this video, please give it a like. If you wish to further explore conceptual modern physics, subscribe to my channel and join me in the Physics Directive. Long live the Empire!